So we have a spherical balloon, and we're told that the radius is increasing at a rate of 5 millimeters per second. And we're looking for the rate of increase of the surface area of the balloon when the volume is 36 pi cubic millimeters. So whenever you have a rate of change problem, the first step should always be identify what you're looking for. So we're looking for rate of increase of the surface area. So that's going to be, means we're looking for ds dt, because S represents the surface area. And we have a formula here for surface area and a formula here for volume. Now, because we're looking for surface area, let's take a look at that formula for surface area. So that the surface area is equal to 4 pi r squared. So to get the ds dt, what I'm going to do is differentiate both sides of this with respect to t. So I'm going to do a d dt and a d dt. And on the left side, d dt of s is going to be the ds dt that we're looking for. And on the right side, the 4 pi is like a constant multiple, so I don't have to worry about that for the derivative. It just stays the same. And then when I do a d dt of r squared, well, I'm going to have to take the 2 and bring it down to the front as the coefficient by the power rule. And the inside stays the same. And then don't forget the chain rule, multiplied by the derivative of the inside function. So d dt of r is going to be dr dt. And before we start substituting values, I'm going to simplify this a little bit. Know that ds dt equals 4 times 2 is going to give me 8 pi dr dt. Now we can start substituting in, and there's an r here. And then we can start substituting in some values. So we know that the radius is increasing at a rate of 5 millimeters per second. So that means that my dr dt is going to be 5. So I can put down 5 right here, times 5, and then the 8 times 5, I can write that as 40. So I'll just do that for the sake of space. So now, almost done, I just need to find a value for r. All I'm told is that the volume is 36 pi cubic millimeters, but I can use this formula to solve for r. So I know that the volume is 4/3 of pi r cubed, and we're interested in when the volume is 36 pi. And so we want to set this equal to 4/3 of pi r cubed. And basically, the pi's cancel out because we have a pi on both sides, so you just divide both sides by pi. And then when you multiply both sides by 3/4, 36 times 3/4 is 27. So we know that 27 equals r cubed, so that tells us that r equals 3. So this r right here is going to be a 3. So we'll multiply by 3, and this equals to 120 pi. And the units for that is going to be millimeters squared per second, as we can see in our answer choices. So the answer is going to be choice D.